About MongoDB, I assume you already installed this, right? It's already running on your machine, so I'm not going to go over this, right? You download it from mongodb.com, the community edition, right? It's already configured, so if you start it from your command line, right? If you're on a Mac, you would do you would do sudo mongod, and you would with your password, it starts up, right? Once it starts up, oops. Right, starts listening at the common port 27107. Now you should have added the bin directory for Mongo to your path, so you can run mongod from anywhere in your path, right? Well, on that same bin directory, you have another executable called mongo. So mongo is it's a client, right? It's a command line client that allows you to administer or interact with MongoDB, and just like MySQL has a MySQL executable, right? That allows you to interact with that database. There's some other GUI based clients, right? But we're going to cover just Mongo, the command line interface, right? So here you have commands such as show databases, so you can list all the databases so far. Here we have one that I created this morning, webdev summer 1 2017, right? And you can do that just by saying use, right, and then the name of the database. Now in that database, we can store objects, right, and in what are called collections of objects, right, and these are the analogous of SQL tables, right, and SQL records, right. In SQL, we break up the data into tables, right, and then each table will have many records inside, right, and the intention of tables is that you identify certain types of objects that you want to store. And presumably these objects have the same schema, right? They have, for instance, you might have users, and all users have username, first name, last name, password, and so on and so forth, right? And so and you want to group them all together into a table of users, yes? And each record represents an individual user. So the analogous here in MongoDB is that we have instead collections, right? And think of them as arrays of objects, right? Or like in Java, we have collections in Java, right? There's an API for collections. And so once you're in a particular database, you can show all the collections, right, by show collections. Here we have two collections. One is a to-do collection and a to-do models collection, which we worked on earlier this morning. For this class, we're going to create a couple more collections. Let's create a collection to store blog entries, yes? And to do that, you can use the DB prefix that tells us that we want to manipulate something in the database, right? And then it's db dot followed by a collection name that we want to manipulate, right? So we could manipulate any of these two, the to-do or the to-do models, or we can create a brand new one. So let's create a brand new one. Blog post, okay? And so this says that I want to manipulate the blog post collection, but the blog post collection doesn't exist, right? So just to create a collection, you just need to insert an object instance into a collection, and it will create the collection for you with this very first object inserted into the collection. Yes. So to insert, you just use insert. Notice the syntax is very object-oriented, as opposed to SQL. SQL tries to be pseudo English interaction where presumably you're having a dialogue with the system, right? Select from or insert into database table and so on and so forth. Here it doesn't try to do any of that, right? So it's very object-oriented. db.blogpost.insert, and it's a function at the end. And this insert takes as argument an object instance, right, indicated by the curly brackets. And in here, the curly brackets, you can provide any number of name-value pairs, right? That the names will be the field names, right? And the values will be the values for that particular attribute for this particular instance, right? So in here, you might have the title of your blog, right? So in here, you might have new videos available. Okay, and then you might have a content, right? The content of that blog. So you might have content, right? Videos are now available. Oh my goodness. I think that's because I made this too big. Anyway, this says that it inserted one blog post. We can insert yet another one. Let's change the title. We might say GitHub code updated. Okay, so it says, and the content might be code from today's lecture is now available. Okay, so we've inserted two records, but we don't call them records in MongoDB. We call these documents, right? Each object instance is referred to as a document. Okay, and the collection of objects is called just collection. Right. So if you now show the collections, indeed we have this blog post in there, right? We can now retrieve the content by using another command, db.blogpost dot, and if you want to retrieve all of them, you can use a finder methods, find and then parentheses. Now find is a function that behaves differently depending on the arguments. If you don't give it any arguments, it interprets that as you want all the elements in the collection, right? All the documents. So indeed, it returns the two objects that we had initially inserted in there. Notice that our attributes, our properties are there, right? The title property is there, and the content attribute is there, right? With the content that we had originally added. But notice that we have two more attributes there that we had not added there. See that? And there's the underscore ID, right? And these are primary keys that are added by MongoDB for you, right? As opposed to in SQL, if you want primary keys to be added automatically, you need to configure the database to use either sequences or tell it to auto increment, right? Here you get that by default, right? By default, I want to have a primary key. Notice that the field starts with an underscore, right? And an underscore typically means that this is a managed field, right? That is being managed by the infrastructure or by the vendor. So you should not use this underscore ID for your own purposes, okay? Now the default behavior is that it will create the primary key for you, right? You could decide that you want to create the primary key. Right? You can override it and says, no, don't create the primary key for me. I will create it on my own. You know, if you want to use a primary key like a username or you want to use like an email, you can certainly do that. Okay, but it's much easier to let it decide on its own primary key. Right? If you want to add other keys that are unique keys, you can certainly do that. Right? Like usernames or emails, and you can decide them that they are unique. Okay. Yes.
When I ran show collections, other than blog posts, it shows for me system.indexes. What's this collection? You don't have system.indexes.
So the that's used for internal purposes for indexing purposes, right? Which will run indexing. You can ask it to index all this content for improving performance.
Yeah, but I wondered why when you ran show collections, it didn't show up for you.
I don't know. Show DBs. Probably if there was a default.
I'm using the same database as you webdev.
The tests. I don't know what version. Version of Mongo are you using? The latest one?
Yeah.
Yeah. Not sure why. Yeah. The test maybe. Yeah, it's not in there either. Maybe I'm using an older one than you. So this one. All right. So show collections. So blog post. So we can use db.find blog post.find, and that retrieves all of them, all the items. If it's too big to read on one single line, you can ask it to pre-print the content, right? So that it will instead print each field in its own line. Right? So it's a little bit easier to read. Now, final by itself retrieves all the elements, right? But you can ask for an individual element, right? So you can add an optional filter here that it's the equivalent of select star from, right? And then you can give it a where clause, right? In SQL. So here, for instance, I want to retrieve the element whose title, right? Whose title is equal to new videos available. Right, and you can, sorry, you put it in here, and notice that it returns just that one element. Yes, and now you can in your filter here we're only matching the title, right? But if you have many fields, right, you can give it several fields, right, and they all have to match, right? So it would treat them as an and, meaning this has to match, and the other field has to match, and the other has to match, right? Without you having to use any operators, and operators, right? Although if you want to do and, or, then you do have to use operators, right, to use your own Boolean expression. And certainly Mongo supports all sorts of Boolean expressions. Also supports things such as like, being able to do regular expressions, greater than, less than, in, all those kinds of things that relational databases support are also supported here, and we'll play around with that as we go on. All right, so that's find. You can also change something. So, for instance, you can update data that is already there. So, for instance, you can do update, and so the first update takes two arguments. The first argument is the filter and says, well, which element do you want to update, right? And so I'm saying, well, I want to update the document that has the title "New videos are available," right? And then the second argument takes what is it that you want to update? What do you want to change, right? And so, for instance, this new videos are available. It says videos are now available. We can update that and using the set operator. Okay. Notice that it starts with $, right? So this means that this is a command by the that is provided by the underlying framework. They all start with $, right? So there's $and, there's $in, $not, $or, there's a whole bunch of them, $in. And this one, the $set takes an argument that says what field do you want to update. So we can change the content. You can say I want to change the contents to be actually they will be available later tonight. Okay, and notice that it comes back with a status saying that there was one match and there was only one document that was modified, right? So it returns the status, and we can do a pretty print to see that indeed it has been modified, right? Actually, they will be available tonight. All right. Now you can also remove an element, right? You can say you can remove that one element. the one that matches that criteria, you can say remove. Now remove. Remove. If you don't give it any arguments, right? If you don't give it any arguments, it doesn't behave. It doesn't behave like you would expect in SQL. In SQL, if you do a remove, you don't give it a where clause, right? It just removes the entire content of the table. Here, the default is not to remove anything, right? So if you don't give me anything, I will not by default remove everything. But if you give it a where clause that is empty, that does remove everything. So careful, right? So curly brackets means matches everything, right? Matches all the elements, right? So careful with that. So we could remove just that one element that matches the title new videos available. So we can say remove. Right, it comes back with a status saying that yes, one element was removed. If I try to run that again, it says no, there was no matching, so I didn't remove anything. Right? Since we removed that, if we run a find, you will notice that we just have that one last element right in there. Right? But before we remove this one, I just wanted to show you that in the insert, where's our insert? Let's go back to insert. Insert. Notice that we were using as field names, title, and content. Yes? And we had added two documents in here, and they both had title and content. Right? So it seemed like we were following some schema, right, where all fields had to have the same name, right, and perhaps the same data type. But actually, MongoDB doesn't care. Right? It doesn't really care what the field names are, and it doesn't validate any of those fields. So if I had forgotten what this field was, and I thought it was body, by the body of my post, right, and I enter, it inserts it just fine, right? So that if I do a find, notice that here I have a document that has title and content, and this one has title and body. Right? And Mongo doesn't care, because in Mongo there is no notion of a schema, right? Where each record has to match a particular schema. Okay, we don't have that in Mongo, and again, the idea here is that we're just storing object instances, right? And not that you would do something like this, and obviously we would encourage you not to do this, right? Yes.
I noticed sometimes you use quotes, sometimes you don't.
Okay. Yeah, so in the Json syntax is to always use double quotes. Okay. The browser and the IDE is friendly. It understands when you leave out the quotes, but it understands that you mean double quotes everywhere. Okay.
You don't have double quotes there, though, the body.
Right. So exactly. So it understands that this is a title. It's a field. Right. It's a name value, name value, name value. So all names have to have quotes. Right. So it will quote it for me. Notice that when it gets inserted, it does add the quotes. Right. Right. So, but the proper syntax is always using the quotes. Right. It's just that it's friendly. It understands that all the names are quoted. Right. So it'll quote it for me. Also in JavaScript, when you code and you put JSON, also the proper thing would always be to double quote. Right. But JavaScript on the browser, it understands the syntax. Right. It will quote it for me. Okay. But if you store it in an actual JSON file, right? It'll a JSON file. Those have to be quoted, otherwise it will be considered to be bad configuration. Yeah. So in a JSON file, you are forced to put the quotation marks. In JavaScript, you're not forced to use the double quotation marks. Yes. Yeah, all the major data types are supported. So numbers, you would not quote it. Yeah.
Like
the value.
Like if you mango like numbers.
Yeah. So you could insert, and here would be count. 1, 2, 3. You would not quote it. So when you're doing the find, it would not be quoted. So all the major data types. So dates are also supported, and those will not be quoted either, right? But it would be stored as an instance of a date object. Yep. Okay. And notice that one of the cool things is that once you're inserting the fields can actually be nested objects. So you could have objects of nested objects of nested objects of arrays of nested objects of a nested array. So you can store objects as complex as you want, right? So you could have here you have a post, and you could have maybe a comments, or comments could be an array, right? And each comment can be different objects in there, right? So this could be the title of a comment. So this could be comment 1, and this could be the title of another. This be title of another comment 2. Right? And if we do pretty, notice that we have an outer object that contains an array of objects. Each object could have another array, right? Or could have an object that has arrays, that has objects, that has arrays. So arbitrarily complex objects you can store in there. So that's why we refer to this as kind of like a document, right? Like a JSON document, or like an XML document, right? Just storing arbitrary data. Yes? So it's not a record per se, right? It's an object instance that we're storing in there that you can then read back from MongoDB and have an instance in Node.js. Make sense? All right. Okay. If we remove, right? If we just say db.blog post, and we say remove and not give it any predicates, right? It removes all 4 elements. They're all gone, right? So if I do a find, it comes back as empty. Show collections. Blog post is still there. You could drop the entire collection, right? Just start all over. So blog posts, we can say drop, and then it's the collection is no longer there. Everybody okay? All right. All right, so those are the the absolute minimum that we need to be able to just interact manually, right? And certainly there's quite more that we can chat about. But the more interesting part is to interact with this from a Node.js application, right? So let's talk about that next.